So here we have the sequence A1, A2, A3 all the way up to AN. These sequences are in harmonic progression. Then we need to verify the following. So let us begin. Now it's given here already that the sequence A1, A2, A3 all the way up to the nth term AN, these terms are in harmonic progression. So if they're in harmonic progression, that it immediately means that the reciprocal of each term is going to form an arithmetic progression. That means 1 over A1, this is the first term, followed by 1 over A2, then we have 1 over A3 all the way up to the nth term, which is 1 over AN. These terms are going to form an arithmetic progression. That's fine. So if they're forming an arithmetic progression, now let's define the common difference of the arithmetic progression. So let the common difference of the arithmetic progression be D. So how do you find out D? To find out D, all we have to do is take the second term, which is 1 over A2, and from it subtract the first term. And then this is going to be A1 minus A2 divided by A1 times A2. So this is D. Similarly, we can also define the common difference. That's why it's called a common difference. That means we should get the same value if we take the third term and from it subtract the second term. So that means we have A2 minus A3 divided by A2 times A3. So this is also going to be the common difference D, and so on. Similarly, we can define for the last term, so we can take 1 over AN and from it subtract the second last term, which is n minus 1. So we'll have AN minus 1 minus AN divided by AN minus 1 times AN. So this is the common difference. So now what we'll do, now that we have the common difference, let's try to extract A1 times A2, A2 times A3 from each of the common difference, because we'll be needing them. Okay, fine. So what we'll do, we can rewrite this as A1 times A2. So this will be simply equals to A1 minus A2 divided by D. Then we have A2 times A3. So this will be equals to A2 minus A3 divided by D. So this is going to continue. And then we have AN minus 1 times AN. So this will be equals to AN minus 1 minus AN divided by D. So let's do one thing. Let's add each of them. So we have A1 times A2 added to A2 times A3. So this goes all the way up to AN minus 1 times AN. So here we can take 1 over D as the common factor. So we'll have A1 minus A2 plus A2 minus A3, and goes all the way up to AN minus 1 minus AN. So here we can cancel out negative A2 and positive A2, negative A3 with the next term. So here we'll be left with only the first term and the last term. So this will be equals to 1 over D multiplied to A1 minus AN. So let's keep it aside for the time being. Now, in the arithmetic progression, the one that we chose, which is 1 over A1, 1 over A2, all the way up to the nth term. So here the nth term will be given by 1 over AN. So it is simply the first term, 1 over A1, added to n minus 1 times the common difference D. Fine. We'll keep it aside as it is, as D. So let's rewrite everything. So we have 1 over AN minus 1 over A1. This will be equals to n minus 1 times the common difference D. So we have A1 minus AN divided by AN times A1. This will be equals to n minus 1 times the common difference D. Now what we need is here is A1. So this can be also rewritten as A1 minus AN divided by D. So this is simply equivalent to n minus 1 multiplied to A1 times AN. So what we can do, we can replace this particular value with n minus 1 multiplied to A1 times AN. And therefore we have successfully proved the given expression is true. Hence proved.